Hematinics refers to the agents that are used either in the treatment or prevention of anemia. So the agents that are used in the treatment and prevention of anemia uh, are usually agents uh, which are used, which have got a role in either the development and have got a role in the development and maturation of RBC. Okay? The red blood corpuscles. Okay? So that's how we define hematinics. So hematinics are pharmacological agents which are used in the treatment or prevention of anemia. Okay? So these agents, their role is in the development and maturation of RBCs. Okay? So what are these agents? So the agents, we can classify the hematinics as iron preparations, and maturation factors. Okay. There are also uh, adjuvant hematinics. Usually, along with hematinics, we also come across references to erythropoietin. Erythropoietin and its analogs. Um, but strictly speaking, hematinics refers to the nutrients which are used in the which are which have got a role in the development and maturation of RBCs. Okay. So strictly speaking, erythropoietin and erythropoietin, which is a hormone, typically does not fit into the classic definition of hematinics. Okay. Meaning hematinics referring to nutrients which are used in the growth and development of RBCs. Okay. However, in many textbooks, along with hematinics, we also find a reference to uh, the hormone erythropoietin and its analogs. Okay. So for the sake of completion of discussion from that viewpoint, we would also be talking a bit about erythropoietin, but keep in mind that this does not strictly fall within the definition of the classic understanding of what hematinics are. Okay? So how are we going to go about our study? So what are we going to cover in this lecture? We're going to talk about the role of iron. We'll have a big picture. So this would be the big picture. Okay. Then we'll look at how iron is absorbed, how it's distributed, and how it's excreted. Okay. We would also talk about the toxicity of iron. We'd have an idea about the dose of iron preparations. Um, So when we complete our discussion of these points, we would have understood the pharmacology of iron. Okay, which brings us to the question: what exactly are the agents which are used as hematinics? Okay, so from this discussion, we know that iron is one. Okay, so hematinics, iron, and maturation factors. Okay, we already alluded to. Okay, these agents are involved in the development as well as maturation of RBCs. So, what are the maturation factors? We have got folic acid and vitamin B12. Okay, so these are the maturation factors. So iron preparations, pharmacology of iron. So here when we say iron, we mean iron preparations. Okay. So let's put that in a bracket. Iron preparations, meaning pharmaceutical agents, and those we can subclassify them as oral and parenteral agents, and there are also adjuvant hematinics. Okay, so that is a listing of the agents that we will be discussing within this lecture. Okay. So at this point in time, we understand hematinics as the classification of hematinics as iron preparations, maturation factors, and adjuvant hematinics. Okay. So adjuvant hematinics, let's just list them for the sake of a big overview picture. So copper, okay, pyridoxine, riboflavin. Okay. So those are the adjuvant hematinics that we might be talking about. Okay. So if we look at many textbooks, we would also see a reference to erythropoietin. Okay. But erythropoietin happens to be a hormone. So the classical definition or the understanding of hematinics is that hematinics refer to nutrients. Okay, and those that we have listed up there as the classification of hematinics are basically nutrients. Okay? But erythropoietin happens to be a hormone which is not a nutrient. Okay? Therefore, strictly speaking, erythropoietin doesn't come within the classification of hematinics, the classical understanding of what hematinics are. Okay? But for the sake of completion of our discussion, we would also include a brief overview of erythropoietin and its newer analogs. Okay? Um, but bear in mind when we say hematinics, we are referring to iron preparations, the maturation factors, and adjuvant hematinics. Okay. Okay, so we begin with iron. So what are we going to talk with respect to iron? We're going to talk about the role of iron, why we're talking about what's the role of iron in the development of RBCs. Okay, we're going to talk about the absorption, distribution, and excretion uh, absorption, distribution and excretion of iron. Okay. Distribution and the excretion of iron. Okay. We are also going to talk about toxicity and the dosing of iron. Okay. So let's first look at the big picture. And the big picture goes thus. Okay, so let's represent this as the plasma. Okay, so the iron that is absorbed as part of food gets into the body, let's say per day roughly 1 to 2 milligram. Okay, and it is also excreted out of the body, similar. Whatever comes in, roughly that same amount gets excreted. How? Through the sweat, through the stool, okay, basically through this two uh, uh, medium, it is excreted out of the body. Okay, um, and then it is also stored within the body. Okay, so it's stored in the form of ferritin, hemosiderin. Okay, it's stored as myoglobin, certain enzymes like cytochromes. Okay, so you might be familiar with cytochrome P450, which is involved in the metabolism of the body. Okay, and it is stored in certain cells which are localized in certain organs of the body, like the liver, the Kupffer cells, and so on. Okay, so in the plasma. Okay, um, so plasma forms part of the blood, and the blood we know that there is erythrocytes. Okay. So erythrocytes are formed in the bone marrow. Okay. And many of these erythrocytes, when they pass through the spleen, and they pass through the spleen many times, um, they get deformed, and the erythrocytes are alive for maybe 120 days. So after that, they reach the end of their lifespan, and then they are recycled by the reticuloendothelial system, and the iron that's present, it goes back into the plasma, and so on. From the plasma again, it goes into the bone marrow. So that's the cycle of the RBCs. Okay. So in all these processes, we see that the iron is important. We see that iron is important. Okay. So in the erythrocytes, what do they do? We have got erythrocytes, let's say. Within the erythrocytes are the RBCs, remember? Okay, they are the RBCs. And within the RBC, that's an RBC, uh, that's a representation of the RBC. So within the RBC, um, we can see molecules of hemoglobin. Okay? Now this hemoglobin, uh, it's a porphyrin structure. Okay, porphyrin, it's made up of 4 pyrrole rings. Okay, and in the middle of those 4 pyrrole rings, we find iron in its ferrous form. Okay, so you got iron conjugated to 4 pyrrole rings. Okay, and that happens to be the structure of hemoglobin. And why is hemoglobin important? Because we all know it carries oxygen, okay? To all parts of the body, basically to all the cells which utilize the oxygen for aerobic metabolism. And then, the body can't do without oxygen. Okay? So this iron is critical to carrying oxygen, and therefore that is the big picture overview of the importance of iron. Okay? Okay. But iron has got a problem. Okay? So iron, uh, though it's very important in this aspect, it has also got an Achilles heel. Okay? So iron in its ionized form is toxic. How is it toxic? It can result in the generation of free radicals, and those free radicals, they are highly energetic particles, and they can cause lots of damage to the body. Okay, so free iron in the ionized form is toxic. Okay, but the body needs iron, right? So what the body does is it minimizes the amount of free iron. Okay, so how does it do that? It conjugates it with lots of other proteins and stuff, and that's how the body um, protects itself from the harmful effects of free iron. Okay? And that's important when we're going to talk about the absorption, distribution, and the excretion of iron. So, yeah, so that is why uh, the body has got strategies to prevent the free iron from moving around the body. Okay, so what does the body do? It has got special mechanisms for absorption, for the distribution, and excretion. Okay, so for almost all the other nutrients that the body takes in, it has got a well developed excretory pathway. Okay, but the excretory pathway is not well developed as far as iron is concerned. Okay, so there are no specific, specialized mechanism for the excretion of iron. Okay, and if you don't have very good mechanisms for the excretion of iron, then you try to optimize your absorption and availability of iron. Okay? So that's what makes this study of iron very interesting. Okay? So let's get into the nitty-gritty of it. Okay? Let's try to understand these points. Okay. So suppose a person is consuming iron-rich food through the oral route. Okay. By iron-rich food, let's list some iron-rich food. We've got offal like liver, say egg yolk, beans, yeast, uh, say meat, fish. Okay. So let's assume someone consumes this iron-rich food through the oral route. Okay, and all these things contain iron. Meat and fish and liver. Uh, the iron is in the form of heme. Okay, it's in the form of heme. These things would contain inorganic iron. So usually that would be in the form of ions, okay, inorganic ions. So you will have ferrous form and the ferric form. Okay, so um, this is the oxidized form, and that's the reduced form. Okay, so a person who ingests iron-rich food is basically ingesting heme as well as iron in its ferrous and ferric form. Okay, so you're consuming it through the oral route. Okay, this is per os. Okay, per oral through the oral route through the mouth. So it reaches the stomach. Okay, in the stomach, the pH is acidic. You've got the acidic pH. So what happens is there is a reduction of iron into its ferrous form. Okay, so predominantly the iron that would be present would be the ferric form. At the same time, remember, we have also consumed, the person has also consumed heme. Okay? So both these things are present in the stomach. All right, so from the stomach, this consumed heme and iron, it um, enters into the upper part of the lower GIT, okay, which is the duodenum, the jejunum. Okay, so maximum absorption takes place in the duodenum. But remember, in the duodenum, the pH is alkaline. Okay, so it's an alkaline pH. Why? Because you've got all the secretions coming from the hepatopancreatic duct, okay, which has got bile salts and stuff, uh, which makes the acidic contents which come from the stomach converted into an alkaline environment. Okay, what that does is the heme remains as such, and the ferrous form gets converted into the ferric form. Okay, this ferric form, there is a problem. Okay, it is not very soluble. So if it's not very soluble, it's very difficult to becomes difficult to absorb. Okay, remember this heme is now present. Heme and the uh, ferric salt is present within the duodenum. Okay, so maximum absorption we said takes place in the duodenum. So it's somewhere there. It's in the duodenum, right? So this duodenum, um, there are cells here. Okay, uh, enterocytes. Okay, enterocytes meaning the cells of the enteron, which is this intestine. Okay, okay, so we've got the ferric form as well as heme. So let's blow one of these cells up. Okay, so let's make it like so. There is a brush border in the facing the lumen, and then there is a basal layer. Uh, yeah, and so this is the lumen. Okay, so here is the brush border, and that's the brush border that we have drawn here. So that the ferric form and the heme, it is present within the lumen. Okay, So that's the lumen that we are talking about here. And this is the basal surface. Okay. So this we have drawn in two-dimensional structure, but the cell is actually three-dimensional, so therefore you get a surface out there. Okay, so there is a basal surface. Okay. Now, this ferric form, we said that it's not very soluble, right? Okay. So if we look at this basal surface, there is a transport site for heme. Okay, so this heme enters through this transport site. Okay, okay, heme enters through um, this particular site, and we call it this the heme transport. Okay, heme transporter. Okay, so that's the heme transporter. Okay, there is also a site where ferrous ion can enter. Okay? So this is divalent ion. So ferrous ion can enter through this transporter, and it's a divalent. So this transporter is called divalent metal transporter, right? Divalent metal transporter. Okay, let's write it down here. DMT is divalent metal transporter. Okay, 1. Okay, so DMT 1. Okay, but we said only it's only the divalent metal ion can enter here. But what we have in the lumen is a trivalent, the oxidized form of iron. Okay, so we have got actually 3 plus. Okay, there is a clever little enzyme on the surface of the enterocyte, which um, we call ferroreductase. Okay, ferroreductase. So why is it called a ferroreductase? Because it reduces the Fe3 to Fe2. Okay? It reduces Fe3 plus to Fe2. Okay? And this resides on the surface of the enterocyte. Okay? So this is the enterocyte. Okay? Ferroreductase. So here what happens is the ferric form gets converted to ferrous form. Okay, there is a reduction of the oxidized form, meaning there is a requirement for an electron. Okay, if an electron goes there, this gets reduced to ferrous form. Okay, so this ferroreductase, we know its function. It reduces ferric to ferrous, but it needs an electron, right? That electron it obtains from ascorbic acid or vitamin C. Okay, so vitamin C it transfers an electron, and that electron basically reduces this ferric to ferrous form. And once it becomes a ferrous form, it gets into the cell via this transporter. Okay, the divalent metal transporter. Okay, now we've got heme, which has entered into the cell, and we've got the ferrous ion. Okay. Now what happens is this heme gets oxidized, okay, by something called heme oxidase. Okay, let's write it down here. Heme oxidase. So heme oxidase oxidizes the heme molecule and releases the ferrous ion. Okay, this ferrous ion can be stored conjugated to a protein which is called ferritin. Okay, so there is a protein that is called apoferritin. Apoferritin, when it conjugates to iron, okay, we call it ferritin. So ferritin binds the uh, ferrous ion, and in this binding, what happens is this ferrous gets converted to ferric again. Okay, so the whatever the ferrous ion is present, it gets converted within the cell to ferric form, and that ferric form binds with ferritin. Okay, so the bound form is in the form of it's a ferric form. Okay, then what happens? There is a transporter at the basal layer of the um, enterocyte. Okay, and it has got two parts. The first part is called hephaestin. Okay, hephaestin, and hephaestin is combined with the transporter which we call ferroportin. Ferroportin. Okay, so hephaestin, it's conjugated, it's combined with another protein called ferroportin. Okay, so this ferrous ion can exit through this ferroportin. Okay, uh, at the basal layer you got blood. Okay, so let's draw a blood vessel. Okay, so that's a blood vessel. Okay. So this ferrous form, it enters into this blood, and immediately it gets uh, oxidized to ferric form. Okay, so in the blood there is apotransferrin, which is a protein, and it combines with the ferric ion, and it forms the transferrin. Okay, transferrin. So again, transferrin is it combines with the ferric form. So it is as this complex that iron is transported within the blood. So in this form, it will be transported. Where to? It can be transported to the bone marrow. In the bone marrow, it can be conjugated to form heme. Okay, and that heme will be transported within the RBCs, and then yeah, we get hemoglobin. Okay, yeah, and it is also transported to cells which take it in and then um, form this storage form of iron, which is again ferritin. Okay, in some cells, this ferritin gets combined, and then it combines with lots of iron to an extent that almost 50% of this complex with the ferric form, when it reaches about 50%, it becomes very concentrated within the lysosomal membrane in certain cells, and that we call it hemosiderin. Okay? So that combination we call it hemosiderin. Okay, all right. Okay, it's transported as hemosiderin. Okay, so from this there are lots of take-home points. Okay? So we need to understand that the transport form of, the storage form of iron is ferritin and hemosiderin. Okay, so the storage form of iron within the body is ferritin and hemosiderin, the storage form. Okay, and it is transported in the blood as transferrin. In the blood, it is transported as transferrin. Okay, and yeah, so that's something that we need to keep in mind. Okay, all right. So let's revisit what we learned here. Okay? So okay, sorry for that. Yeah. So um, here we said that the iron after ingestion, whatever happens, right? Um, um, it gets into the stomach. Okay, and suppose at this time the person is also consuming, say, antacids. Okay, if at the same time that the person is taking heme and this iron-rich compounds, if the person is also consuming, say, for example, antacids, or they are consuming, say, phosphates, or say phytates, okay, or maybe a drug like tetracycline. Okay, what could happen is it can interfere with the absorption of iron. Okay, so these things can form a complex with iron, and then once they form the complex becomes insoluble, and therefore there won't be absorption. Okay, so this is a drug interaction. Drug interaction in absorption. Okay. Okay. For iron. Okay. So let's keep that in mind. That compounds like antacids, phosphates, phytates, and tetracycline like drugs can complex with the iron. Okay, so let's write it down. This can potentially complex, can potentially complex with iron, and thereby it can decrease absorption. Okay, that could be an absorption drug interaction. Okay, these antacids, they are alkaline, so think about it. The stomach, the pH is acidic, and that can be converted by antacids into the pH can increase, pH can become alkaline, and when that happens, what can happen? The ferric form will predominate. Okay, and that highly alkaline 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 medium comes lower down into the jejunum, and again, so all in all, the absorption of iron would reduce. Okay, so those are the important things about uh, what can happen during absorption. Okay, so as healthcare providers, we need to be cognizant of this fact. Okay. Okay. So all in all, let's summarize what we have learned. Okay. So iron is absorbed. Okay, and it is absorbed in the ferrous form. Okay, so that's the form in which there will be maximum absorption. The ferric form is not very soluble. Okay, and it is distributed after it reaches the blood. What happens? Yeah, let's recap. Once it reaches the blood, it is transported along with transferrin. Okay, so that's the distribution part. Let's bring it out here. Okay, so distribution, it is with transferrin. Okay, we haven't talked about excretion, so let's get right into it. Okay, excretion. Okay, so this enterocytes line the enteron, right? Okay, so after some time, what happens is this cells which line the intestine, they get sloughed off. Okay, they will die, or they'll be removed into the lumen. Okay, now we have already discussed that iron is stored as a complex of iron and ferritin, and in some cells it is stored as hemosiderin, right? Okay, so if there is a cell that lines the intestine and it has got all this ferritin and hemosiderin within it, and it sloughs off, okay, it dies, it goes into the lumen of the intestine. Okay, then what happens? It takes with it ferritin as well as hemosiderin. Okay, and then that will enter into the intestine, and then it will be lost along with this stool. Okay, so that is one of the ways in which iron is excreted out from the body through the stool. Okay, it's also excreted in the sweat, which we alluded to earlier. Okay, so that is what uh, we need to um, understand when we talk about excretion. So the enterocyte, which sloughs off, carries with it iron, which is eventually excreted in the stool. Okay. Okay. So this stool, um, if it contains iron, it will turn black. Okay. So patients who are consuming iron preparations, it should be informed that it's likely that their stool might become black. So when we counsel a patient, we need to make them cognizant of this fact. Okay, it might remove undue worries later on if they find suddenly their stool to be, of a different color than what they are used to. Okay. So this is one of the counseling points when we talk about iron preparations, and we counsel the patients when we discharge them, okay, with prescription. Okay. Yeah. So, um, yeah, there is one more point that we need to understand before we conclude this segment, and that is that there is a protein which is produced by the liver. So the liver produces a protein, and the name of that protein is hepcidin. Okay, hepcidin. Okay, the liver produces many proteins. So one of the proteins that we are concerned with respect to iron absorption is hepcidin. So this hepcidin has got this interesting property. Okay, it normally so when the iron stores in the body are full, okay, so when the body doesn't need much of iron, what happens is the liver produces lots of hepcidin. Okay, and this hepcidin will inhibit ferroprotein. Okay, the ferroportin transport system. So if it inhibits ferroportin, what happens? More iron doesn't reach the blood. Okay, so this is when does that happen? When the body has got enough stores of iron. Okay. Which means if the um, if the iron stores in the body reduces due to any pathological condition, the liver will uh, decrease the amount of hepcidin that it produces. Now, if there is less hepcidin, what would happen? The inhibition on ferroportin would decrease, and as a result, more and more iron would get absorbed. Okay, so yeah, so with that, we let's conclude our discussion on the on iron. Okay, so we've talked about the fact that we've talked about the fact that iron, if it's in its unconjugated form, when it is free, then it is toxic to the body, right? And because it's toxic to the body has got strategies to prevent the um, the free iron from sticking around. Okay, so what does it do? It conjugates itself. It conjugates iron with proteins so that free iron is not found in the body. Okay, and we've talked about the absorption, distribution, and the excretion of iron. Okay, and we've talked some important counseling points as well. Okay, so with that, let's conclude this segment, and I'll see you in a bit with the continuation of this lecture. Thank you for your